Hello, good afternoon. We are finally at the end of the first order system. This is part 3 of first order system. By this time, you should be very familiar with the first order system. So in this, we look into quickly impulse response, ramp response, and we'll conduct one tutorial because we'll learn only by doing. So let us look at impulse response. So impulse, I have told you many times, impulse is kind of a sudden spike, and mathematically it is represented by delta t, and we know by this time Laplace transform of delta t is 1, so RFS is 1, and we know that CFS is GFS into RFS, and for first order system GFS is 1 by 1 plus st. We learn about 1 by 1 plus st, and this is in the time constant form. So if some transfer function is given in some other form, you can always convert into 1 by 1 plus st. So what is CS? GS into RS, and to get CT, we should take L inverse of CS. So GS into RS is 1 by 1 plus st. So CS into RS is GS into RS, which is equal to 1 by 1 plus st, and that is L inverse of 1 by 1 plus st. And this inverse is very easy. For those who are forgotten inverse, I'll remind you, one of the basic inverse which you should know is L inverse of 1 by s plus a is e power minus at. L inverse of 1 by s plus 2 is e power minus 2t. L inverse of 1 by s plus 5 is e power minus 5t. So this, what we will do is, we'll take this t outside. So what will this become? This will become 1 by t. I have taken t outside, so it will become 1 by t whole divided by, I'm not writing it, whole divided by s plus 1 by t. And what is s plus 1 by t? L inverse of s plus 1 by t, or 1 by tau. Tau is a constant, which is a time constant, and 1 by tau e power minus t by tau. So that is impulse response. And as engineers, I said many times, whenever you see equation, you should be able to draw the graph. And whenever you see the graph, you should be write the equation. And you look at this function, the c of t. That means the independent variable will be along the x-axis. This is time. And you should have a feel for this exponential function, okay? And y-axis is c of t. So as t increases, what will happen to this e power minus t by t? I'll pause for a while. You think as t increases, what will happen for e power minus t by tau, where tau is the time constant? It will decay, isn't it? So that is what is happening. When t, this x-axis is time, when t increases, the value of c of t will decrease. And here also, when t increases, it will decrease, and finally what will happen? It will become 0. So when you give an impulse, so that feel also should be there. When you give an impulse to a first order system, there's a spike and it decays off, okay? So that is about impulse response. Now let's look at ramp response of first order system. Ramp response of first order system, the input is ramp. So I hope all of you know this. I want you to forget control system. As engineers, you may go into various things, but wherever you are, you should know that function, okay? R of t is t. That means as t increases, R of t, the input is increasing. And we know the Laplace transform of t is 1 by s square. R of s is 1 by s square. Therefore, what is CFS? 1 by 1 plus st into 1 by s square. So we got CFS. What is the next step? Take L inverse. So you should be good in L inverse. How will you take L inverse of this? 1 by s square by 1 plus st. How will you find the inverse of this? So is it a by s square plus b by 1 plus st? You look here, this inverse, there are various special cases. You should know all the special cases. There is s square is there. Once s square is there, you have to, we say there is a repeated pole at origin. You should expand it as a by s square plus b by s plus c by 1 plus t. This is the conceptual point. Now you have to find a, b, c. I would recommend that you use method of residues. Use whatever method you want. You find a, b, c. So a is 1, b is minus t, there is a minus here, b is minus capital T, and c is tau square by s plus 1. Now what is CFT? L inverse of these. What is L inverse of 1 by s square? L inverse of Laplace transform of t is 1 by s square. Therefore, what is L inverse of 1 by s square? Is t. And what is L inverse of minus t by s? Is minus t. And what is L inverse of this? You should write in the form s plus 1 by t. So it is t, it is small t minus capital T is a constant, okay, time constant. By this time you know about it. Capital T is time constant, and this is the inverse of the third term. So how will be the graph? You look, you should have a feel for the graph. The small t means what? This is time axis. As time increases, this component will increase. What is this capital T? That is it's a constant. Suppose capital T is 2, means you will always reduce 2 from this. And what about this term? You look into this term, capital T is a constant. What will happen to e power minus t by t? E power minus t by tau. What will happen to this? So it is, as time increases, this term will decrease and go to 0. So let us look at the shape of the graph. This is the expression. This is an increasing term with the time. This is a constant, and this is a decaying term. The graph of ramp response is like this. So this part we will be learning about transient and steady state. This part is called the transient. So when you give a ramp input, slowly the output will increase. After some time, the output will increase at the same rate as the input, but there is an error. This error is called steady state error to a ramp input. This is one of the disadvantages of first order system. If system is first order, then what happens is, if you give a ramp, it will not be able to follow the ramp exactly. That is, you say this ramp input is say a command to a control signal, like we have our water heater. Maybe a more complex system is you have a furnace. The temperature of the furnace, or the temperature of the output of the furnace, you not furnace, you have a boiler in some chemical plant. You want the liquid coming out of the boiler, the temperature should increase gradually. So your command is, you increase the temperature gradually from 0 to 100 degree. So when I say 100 degree, it will go only up to 98 degree. So that is the problem with the first order system. This is called steady state error. So I want you to do this tutorial. I will, at random, I will ask you tomorrow in today's class, whenever in Friday's class, you have to read this question, write the answer, write the expression for unit ramp response, unit step response, and impulse response for a first order system with time constant t and steady state gain k. This all of you know. But what is interesting is, how are they related? I told you in passing, I'll tell you a hint. If you have a step input, if you integrate step, what will be the output? If you differentiate step, what will be the output? Think about it and do this problem, okay? So one more thing is there. All students should do one question so that we can finish in some 10 minutes. So the first 10 students should attempt question 1, next 10 question 2, and so forth. So these are the questions. So the first group 1, not group 1, students from roll number 1 to 10 should answer this. That is, you should answer A, B, C, D, E, F. Your GS is 10 by S plus 2. Another set of student, GFS is 10 by S plus 5. So all are identical problems. Thing is that I don't want you to copy, okay? So what is take home? So I've spent a lot of time on first order system. I know that, because my point is, if you understand first order system well, then you could learn all the other things. The concepts will be clear. And first order system is represented in general by this. What is K? K is called the steady state gain, and what is capital T or tau is the time constant. So if these two numbers completely categorizes a first order system. A thermometer, I told you, will have time constant of 10 seconds. K will be the multiplying factor. So any system, a water heater could be represented by this first order system. So water heater, if like you want to take water on a cold day, the water, say your command is the output temperature should be 50 degrees centigrade. Then it will take, you switch on the heater, it won't be 50 degrees centigrade immediately. It will take some time. It will take 10 minutes, say. Then the time constant is 2 minutes. So this first order system means it is completely parameterized by K and T. And first order system, when you give step input, the shape is like this. It will increase slowly, and then it will reach steady state. That is, if you say 50 degree, it will reach 50 degree. If you say 10 degree, it will reach 10 degree. So that is the meaning of step response. Impulse response, if you give an impulse, the output will, like you give a spike to an RC circuit, the capacitor will get charged and it will get discharged. And then a ramp, I said there is a steady state error for ramp input. So that's all. Thank you.